Good morning, ladies and gentlemen. Welcome to this session, Why, How and What of Highly Modified Asphalt. My name is Eric Scholten. In the next half hour, we have a presentation by Sebastian Puchalski, Global Market Manager, Paving and Roofing of Kraton from the United States. He's not able to join us at this hour, but we have a panel with David Bell, Sales and Market Development Manager of Kraton from the United Kingdom, and Laurent Porot, Market Development Manager of Kraton in the Netherlands. Let's start now with the presentation and we'll get to questions after that.
Our daily lives depend on a reliable road infrastructure. Yet, as with many other things, we often take the roads for granted. Growing population, heavier road traffic, and increasing number and severity of extreme weather conditions resulted in stricter sustainability standards and more comprehensive greenhouse gas emission limits. These changes provide us with an opportunity to rethink the future of the paving technologies. Hyma, or highly modified asphalt, is a paving technology developed to address the needs of modern pavement infrastructure. Yet, why should you be interested in Hyma? How does it really work? And most importantly, is it a proven technology? Let's start with answering the why question. Investing in pavement infrastructure usually takes into consideration the life cycle cost of an asset. Simply put, the life cycle cost is the cost of initial construction, as well as any subsequent maintenance expenses and salvage value, all discounted to present. The Hyma technology has been shown to reduce the pavement life cycle cost. The cost reduction may be achieved in two ways. The first option is to make the initial pavement thinner, thus saving on the cost of materials. The second option is to retain the original pavement thickness and instead rely on the improved performance to extend the pavement life cycle. Sometimes, specific pavement issues take precedence over the life cycle cost consideration. Hyma excels at addressing severe rotting pavement problems by delivering extra material strength. The continuous polymer network helps to eliminate or minimize top-down and bottom-up fatigue cracking. Additionally, the Hyma-enabled asphalt mixtures may drastically eliminate or reduce a wide range of issues including reflective cracking, studded tire damage, extra heavy load damage, delayed post-construction opening time, raveling of open graded asphalt, water damage, curb reveal or road clearance height issues, and problems related to providing sufficient pavement structural support over sensitive utilities beneath. Although reducing the life cycle cost of an asset is important, Hyma may also be beneficial to the environment. Using fewer raw materials and reducing the number of repair and maintenance cycles may have a profound impact on the carbon footprint of a pavement asset. The initial material carbon footprint of Hyma may be somewhat higher when compared to the conventional solutions. However, fewer maintenance and reconstruction operations may allow for a lower overall life cycle carbon footprint of Hyma pavements. Consequently, our society can benefit from lower long-term infrastructure spend and fewer hours lost in traffic jams due to road repair. Let's now discuss how Hyma enables the mentioned benefits. Hyma should really be understood on two distinct levels: the asphalt level and the bitumen level. This is a schematic illustration of a conventional SBS polymer. The solid blocks on both ends allow the polymers to assemble together in bitumen. They also give the PMB its strength. The rubber segment in the middle makes the PMB elastic and resilient to cracking. The durability of the polymer network grows as the dosage of the polymer in bitumen increases. In this demo, the polymer modified bitumen samples containing different SBS dosages were subjected to a creep test at a room temperature. Increasing the polymer concentration visibly led to significant gains in the material strength. This phenomenon is often characterized using an S-curve analogy. In the lower part of the S-curve, the material acts as a traditional polymer modified bitumen. However, as the polymer concentration increases to approximately 7 to 8% SBS, the material reaches the upper plateau of the curve. In that region, the material starts acting like an elastic band, reaching the continuous polymer network effect. Achieved at a typical SBS concentration of 7 to 8% is very difficult while using the conventional SBS polymers. The very high material viscosity prohibits normal operations of the PMB and asphalt plants. Additionally, the asphalt mixture workability becomes very challenging. To enable the high levels of modification in the paving applications, Kraton invented a new type of SBS polymer. The unique design enabled faster dissolution time in bitumen, enhanced cross-linking capabilities, and ultimately a lower viscosity of the polymer modified bitumen. The unique nature of Kraton's polymer enables creating a dense continuous network necessary to achieve a step change in material performance. This simple demonstration visualizes the strength and the elasticity of bitumen with a continuous polymer network, the kind achievable with the Hyma technology. Although enabled by Kraton's polymers, the Hyma technology itself is not proprietary. Numerous construction material companies implemented Hyma into their product offering. Additionally, a growing number of public agencies used Hyma to improve their infrastructure while utilizing the existing specifications frameworks. However, as with any novel technology, the conventional test limits are often inadequate to properly capture the Hyma PMB unique characteristics. Polymer network is at the core of the Hyma technology. MSCRT, or Multiple Stress Creep Recovery Test, is a convenient surrogate tool for evaluating the polymer network quality in bitumen. Dynamic shear rheometers used to perform the test are sensitive to even small differences in the material performance. Hyma PMBs are typically tested at 76 degrees Celsius and a 3.2 kilopascal stress level, with a specified minimum 90% recovery. At these conditions, only the PMBs with a continuous and robust polymer network can pass the limit. The Hyma PMBs are also specified with a maximum viscosity limit, yielding a material that balances both the material performance and workability. What happens at the bitumen nanoscale has a set of very profound effects on the asphalt performance. Asphalt mixture design is an act of balancing the rutting and the fatigue resistance. Improving one parameter typically comes at the cost of deteriorating the other. The concept of the balance mix design may help to reach an appropriate balance. Nevertheless, making incremental adjustments to the aggregate gradation or the bitumen content has its limits, especially when the pavement structure must be thin or is subjected to a heavy traffic. Conventional polymer modified bitumen offers an excellent but limited solution to this problem. The Hyma technology offers a more powerful solution to easily address both fundamental distresses at the same time. To illustrate the unique capabilities of the Hyma technology, we've prepared a set of demonstrations utilizing small asphalt mastic specimens. The specimens were made with 90% washed sand and 10% bitumen by weight. Each demonstration features 3 specimens. The first made with a conventional paving bitumen, the second utilizing a 3.5% SBS polymer modified bitumen, and the third made with a highly modified bitumen. The first demo was conducted in an environmental chamber at 60 degrees Celsius, Each specimen was loaded with 100-gram weight. Despite the same aggregate and bitumen content in mastic, the Hyma's continuous polymer network provided a visible improvement in terms of the permanent deformation resistance. At the intermediate temperatures, where the load-induced fatigue cracking usually occurs, the Hyma polymer network allowed for asphalt to reliably recover after flexing. This helps minimizing the crack formation and propagation. The third demonstration concerns the durability of pavements built with Hyma technology. A golf ball falling from a set height will impact each of the three specimens. Both the unmodified and the conventional PMB specimens did not survive the impact. The ability of the Hyma to withstand the impact highlights the unique capabilities of the continuous polymer network. As compared to the unmodified bitumen, the conventional PMBs allow for a step-change improvement to asphalt rotting and fatigue performance. Hyma, with its fully continuous polymer network, take these improvements to the next level. Any comprehensive Hyma technology coverage requires addressing the aspects of asphalt mixture production, paving, and opening to the traffic. The low viscosity nature of the Hyma technology allows for asphalt mixture production process that is similar to that of the conventional PMB mixtures. Additionally, it is possible to produce Hyma mixtures with significant quantities of reclaimed asphalt. Hyma asphalt is relatively easy to handle. The conventional Warmix asphalt technologies can be further used to improve the mixture workability and reduce the production and paving temperatures. After placement and compaction, Hyma mixtures reach the conventional asphalt stiffness at a relatively higher temperature. This characteristic may allow for faster opening to the traffic without risking premature pavement deformation. So far, it's been explained why and how to use the Hyma technology. The third question, perhaps the most pertinent one, remains unanswered. Has Hyma been shown to work in real pavements? To answer this last question, we need to move back to year 2009, when the first Hyma test section has been built at the National Center for Asphalt Technologies in Opelika, Alabama. The Creighton Hyma test section was constructed next to a reference section made with a conventional PMB. The study aimed to demonstrate that it was possible to make asphalt pavements thinner and more resistant to cracking and permanent deformation at the same time. Both test sections were subjected to 20 million equivalent single-axle loads over a course of 5 years. Despite being 18% thinner than the conventional PMB test section, Hyma resulted in 70% less rotting and no bottom-up fatigue cracking, while the control conventional PMB section resulted in 18% of area cracked. In 2010, at the Napier port in New Zealand, Hyma was used to successfully address severe rotting issues stemming from extra heavy container handling equipment. In 2012, Hyma emulsion was substituted for latex-modified asphalt emulsion in the microsurfacing of 4.5 lane miles of local streets in Dallas, Texas. That same year, the Oklahoma Department of Transportation used Hyma to address severe rotting issues related to poor soil conditions on the I-40 highway. In New York City, Hyma thin overlay was used on 53 blocks of Manhattan's First Avenue, which required minimal adjustments of drainage inlets. The Viracopos airport in Brazil benefited from Hyma's superior load-bearing capacity, allowing for a substantial reduction of the taxiway wearing course thickness. In the Brazilian state of Santa Catarina, Hyma helped avoid the full pavement reconstruction. Instead, the top two layers were replaced with Hyma at a fraction of the cost. On the US 90 in Midway, Florida, heavy traffic next to a large truck stop was causing severe rutting issues. A Hyma friction course helped to address the problem in a simple and quick manner. A regional road administration in Katowice, Poland, successfully piloted Hyma, searching for a more sustainable and affordable pavement technology. The MS3 bridge in Ostróda, Poland, features a unique use of Hyma binder in mastic asphalt bridge deck application. In Anchorage, Alaska, Hyma helped to address the rutting problems caused by studded tires, which are commonly used during the winter time. A Tampa field study, conducted by the Florida Department of Transportation, has shown that Hyma was successful in reducing the occurrence of concrete joint reflective cracks and rutting in the asphalt overlay. In 2018, the Hyma technology was used on a tollway in Rajasthan, India, to protect the asset from damage related to extremely heavy traffic and occasional flooding. In 2018 in Prague, a damaged runway was repaved with Hyma while the airport was in operation. As of late 2020, all the mentioned pavement projects continue to provide excellent performance. Whether solving a particular performance-related problem or lowering the life cycle cost, the Hyma technology can provide a unique value proposition in a broad variety of pavement assets. With well over 5 million mixed tons paved and in use around the world, Hyma is not a fad. Rather, it's a proven and reliable technology. It is crucial to recognize that the progress achieved by Hyma would not be possible without the active adoption and participation in this technology by the innovative material and construction companies, the forward-looking road owners and public transportation agencies, as well as the academic institutions, all of whom had a unique and thorough impact on promoting the Hyma technology. If you think that the Hyma technology could benefit your business or improve your asset's value, but are not sure where to start, you're in the right place. In addition to supplying the specialty polymers for the Hyma technology, Kraton provides comprehensive support for parties interested in adopting Hyma. Kraton's Bitumen Innovation Centers, located in Amsterdam, Houston, and Mumbai, provide Hyma P&B formulation and testing assistance. Kraton's commercial and technical team possesses experience and knowledge helpful in tailoring the Hyma technology to very specific project needs. Thank you for your attention, and please make sure to get in touch with us during the E&E Congress.
So with that, we've completed the presentation. Let's have a look at some questions. I'll start here with a question for David. Reviewing all the projects that you have done so far with Hyma, is it fair to say that the balance is mostly going towards layer thickness reduction, or do customers prefer to extend the lifetime? So are they basically, in other words, willing to take the risk to go for the full reduction potential, or is more the improved performance chosen?
Okay, thanks, Eric. Well, overall, if you look at the main criteria for the projects, we can talk about extended performance really as a key driver. So whether this is looking at rutting due to extreme loading conditions, so I'm thinking specifically here back to the project in 2010 where we started in Port Napier. Or if we look at refractive cracking, particularly like in overlay situations on concrete subbases. So I would refer to Hyma as a toolkit technology, whether it's strengthening layers or wearing courses. And in majority of cases, customers have looked for that durability to extend the lifetime. Now, if there is some cost element, particularly upfront costs, so not looking for the value on the longer term, but you also need to balance that with costs upfront. Then yes, certainly there has been a number of examples, particularly in Brazil, where we've seen the customers have opted to look at layer thickness reduction as an option to bring down that upfront cost, but still achieve the required performance, whether that's on equivalent level or even extended over a standard PMB or a standard bitumen.
Okay, thanks, Dave. A question from Martin Hugener for you, Laurent. Is there only one type of Hyma?
Yeah, it's a good question for that. It's fair to recognize that depending on the climate condition from country to country, region to region, we may adapt slightly the Hyma formulation. The main characteristic for Hyma is really having a high performance against the rotting. So the high temperature domain, either if it's softening point temperature or high PG temperature, is always quite high. So we target 80 degrees or 85 degrees for softening point, or PG 76, even 82. And then afterwards, we can identify maybe 2-3 different grades, depending, in fact, the climate condition, to cope with the intermediate temperature. So yes, we may see, in fact, different grades, between 2 and 3 grades, but always with very high temperature domain.
Okay, thank you. And then a question from Christina Smith. Do certain types of procurements make it more likely that Hyma will be specified? For example, DBFO is mentioned here.
Yeah, so well, let's not forget that around the world we have many specifications already in place for a polymer modified bitumen. So as we talked about in the video, what we look to do here is bring another dimension and go a step above those. So whilst the Hyma technology would satisfy conventional specifications, also we need to look at what the actual reason and what the main criteria and the key drivers are for certain projects. So particularly if you're looking to have that durability to remove maintenance cycles, for example. So you're really looking for that longer term performance and cost savings over the life, the lifetime of the road, particularly in these type of contracts. Then yes, you could imagine that Hyma technology would be specified here. In other situations, perhaps where the performance requirements are not as extreme, then other materials may be more suitable or maybe used there. So certainly you need to look at what the key drivers are, what the situations are, and again, this is basically a toolkit technology that we can discuss and adapt into different situations.
Okay, thank you. We've got quite a few questions coming in, so we'll go to the next one from Shaheen Eskandar Safat. How about the recyclability of Hyma?
I can pick up this one.
Okay.
Yeah.
So in terms of recyclability, it's like normal standard polymer modified bitumen. It depends always, in fact, on the polymer you use, and as well the process to do that. Usually Hyma comes with a specific polymer which was designed on purpose to keep viscosity and compatibility with various bitumen to be fully recyclable. And we'll have a poster during the poster session discussing more in detail about recyclability and multi-aging for Hyma binders and polymer in detail. So I encourage, in fact, Shashin to go to the poster session, and we can discuss further about this topic. But we don't see so far, in fact, any problem with that. It has to be laid for 10 years already, some projects where we can start to see some repair and recyclability of these binders.
Okay. The next one from Erik Nielsen. Hyma has a polymer content of 7 to 8%, but with increasing polymer content, the compatibility with repair due to utility works might become difficult. Please comment.
Yeah, so certainly, yes, the content of the polymer is 7 to 8%. Let's not forget that it is uniquely designed polymer. So certainly from the workability of the asphalt mix, that should be at the same sort of level as a conventional product. So we wouldn't see any issues there. In terms of compatibility with recycled asphalts, and then Laurent just talked about that. But yeah, I mean, certainly if you have a freshly laid road surface, it's always a bit of a shame to see utility works coming into that and digging it up. But yeah, as always, you need to look at what the materials are. If we need to replace that with material that's hand working, as I said, even with a higher polymer content, hand working should be feasible with Hyma asphalt.
Thank you. Another question from Martin Vondenhof. How much higher is the modulus of Hyma asphalt compared to standard or Hyma PMB compared to standard PMB?
I can pick up this one again. I would like to say it all depends on the formulation of the asphalt mix. But with the case of Hyma, the binder itself plays a major role in the final characteristics of the asphalt mix. And usually we can see, in fact, stiffness modulus as higher, in fact, as a high quality asphalt mix. So we did some comparison, for example, with the so-called E&E, so high modulus asphalt mix, and we almost meet the same specification of E&E, but with a slightly lower binder content. So it's always a combination of the aggregate skeleton and the binder itself. But at the end, we can almost match the same stiffness modulus than normal mixture or even high performance mixture.
Okay, thank you. Yeah, we got quite a few questions, so we'll see what we can do in the remaining time. Here, a question from Gianpaolo Finati. Did you obtain both lab and field data with focus on aging and degradation of the binder, so to monitor UV and oxidation?
So maybe it's a bit similar question than Shashin. So just come back to the poster. So we did the aging on asphalt mix made in the lab, and as well, in fact, on the binder with that. Surprisingly, what is really interesting with polymer modified bitumen is that you hardly see no change in the softening point or the high PG grade. So it remains, in fact, a quite high level. More specifically, with regards to UV aging, it's always difficult to reply to this question in the sense that the UV impact will be only on the surface and penetrate maybe some micrometer from the surface. So certainly on the surface, you may have some different aging or behavior, but in the bulk of the asphalt mix, it's hardly to affect the aging for that. So overall, aging is similar to normal PMBs. And there are some literature on the web and on researches demonstrating that depending on the polymer and the process, there is hardly no more aging than conventional bitumen. But we can discuss again further during the poster session.
Yeah. Then our last question, because we won't be able to do all of them, from Azim Remtula. How does Haima compare to a combination of stiff bitumen and conventional SBS? Will this provide cost-saving implications? How would that look like?
Yeah, well, the issue with using stiff bitumen and conventional SBS is getting that continuous polymer phase network. As we saw in the video, particularly if you look at these materials under shear DSR situations and using the MSCR test, that's really highlighting the critical importance of a continuous correct polymer network. So you really need to have that compatibility between the SBS and the bitumen. Stiff bitumens, that can be an issue, along with the handling issues. So with using the Kraton D0243 SBS polymer for the Hyma, that will give you the option of a higher polymer content regardless of the bitumen type as well.
Yeah, okay. Thanks very much, David. And with that, we have to finish this session. Thank you, David. Thank you, Laurent, for your answers to the questions. Thank you all for attending this session. When you have further questions you want to discuss further, please visit us at our booth or get in touch directly. Thanks again, and I wish you a very good second day of the E&E conference. Thanks. Bye-bye.